Good afternoon, everybody. This is a live extreme weather briefing with a lot to talk about. You can see that the Atlantic, the tropics, are lit up like a Christmas tree with numerous disturbances to track, including a new one that's forecast to become a tropical depression as early as tonight across far southern Florida before moving into the eastern Gulf of Mexico. And through the weekend into early next week, it is forecast to become a tropical storm across the northeastern Gulf of Mexico. Even a minimal hurricane is not out of the question early next week, somewhere along the central Gulf Coast. So that'll be a disturbance that we definitely need to watch out for. And of course, we have Paulette out in the open Atlantic. We also have Renee, that has been a relatively anemic tropical cyclone, but recently has had an explosion of thunderstorms right around its center. These two tropical cyclones are going to undergo Fujiwara interaction, with Paulette becoming the dominant tropical cyclone, impacting Bermuda potentially here before lifting off to the northeast. That's going to cause Renee, a weaker storm, to bend back to the west due to Fujiwara interaction, and then eventually also lift out to sea. And then we have 95L, a couple of waves also that have emerged off the West African coastline. The one that just emerged from West Africa is supposed to recurve to the north and potentially become a fish storm. 95L. Long-range models, some of them show a recurving storm at different locations throughout the Atlantic basin. Other models bend it back to the west, bringing it close to the Bahamas and potentially becoming an impact for the southeastern or east coast of the United States. But we'll just have to wait and see what happens to that southernmost wave, 95L, as it tracks off to the west. This is the 5-day development graphic here by the National Hurricane Center. And really it's a race to see which one becomes Tropical Storm Sally. Is that going to be this one off the southern coast of Florida that moves into the eastern Gulf of Mexico? Is it going to be 95L? It's probably going to be the tropical depression or tropical storm that is named off the coast of southern Florida. This disturbance also in the Gulf of Mexico right now is the least relevant. That one could turn off to the southwest, potentially coming close to the northeastern coast of Mexico through the weekend into early next week. So right now we've got a very active pattern, but it's the peak season of the Atlantic tropical season. September 10 is the date of that peak, so it's not surprising that we're seeing all these active storms out in the Atlantic. We can break them down on satellite imagery. This is using the Radar Omega satellite imagery plotter here showing the Atlantic, and you can definitely see an intensifying Paulette here that could impact Bermuda as a pretty powerful hurricane. Some of the intensity models even bring this storm up to a Category 3 storm. You can see this potential vorticity streamer off on the northwestern periphery of that Bermuda High. And the Bermuda High is forecast to consolidate a little bit further east, and this storm is going to turn off to the north on the western periphery of that Bermuda High. You can see Renee has a little bit of a convective explosion near the center. It's a much smaller storm. But this latest convective explosion here could be a sign of a bit more organization. And here you can see the wave that everybody's watching, 95L, that is down a little bit further south. And that's why everybody's really concerned about that one. It could take a similar track to Allura, a little bit further south. Some of the models, though, especially the GFS, has them turning to the north a little bit sooner than anticipated. We've got a Rossby wave train in the jet stream here in the mid-latitudes. And really the positioning of this Bermuda High in the subtropical Atlantic determines whether these turn to the north and get picked up by the Rossby wave train, or if they get blocked from that recurvature and then head toward the United States. And we've got this one now, which is a new disturbance that everybody's watching just off the southeastern coast of Florida. It has prompted some special marine warnings along the west coast of Florida with some waterspout potential. And so far, that system is an open wave. It's an easterly tropical wave. It's moving off to the west, but some of those forecasts show that it could develop a closed circulation overnight tonight. And if that happens, then it's going to be named a tropical depression as early as tonight across southern Florida. And if not, then it's likely going to be named a tropical depression once it moves over the open waters of the eastern Gulf of Mexico. And we definitely need to monitor this one for landfall early next week, probably in about 5 days, somewhere in the central Gulf Coast. And if that does strengthen into a Category 1 hurricane or even a strong tropical storm, I'll likely head down there with our instrumentation, the Subsonic sensor. Mike may also deploy with the Windy Palms project to deploy some hardware along the coast ahead of this one. That's a race to become the S storm that could head into the eastern Gulf of Mexico. So quite a complex satellite image here, and definitely a complex look at the tropics. But you can see these multiple storms that we're watching. Again, Paulette could impact Bermuda. We've got Rene, which is going to interact through Fujiwara interaction with Paulette being the dominant tropical cyclone. We have this new wave that's just off the coast of Africa that looks like it's going to take a little bit further north of a track, increasing the odds that it'll curve off into the central Atlantic and become a fish storm. So really the ones that we have to watch are this storm system just southeast of Florida, and also this wave down in the southern stream. There's also another one that we're watching very closely. And let's look a little bit in more detail here at the visible satellite image of that disturbance just off the coast of Florida. I suspect it's going to be named a tropical cyclone here later on tonight, and if not tonight, then definitely as it moves into the eastern Gulf of Mexico. There's been some pressure falls associated with this system, quite a bit of convection as well here over the central Bahamas. The more convection that happens, the more latent heat that's released into the column. That leads to the surface pressure falls, which leads to more convergence at the low levels. And then you eventually will develop a closed spin. That's when it becomes a tropical depression, which increases the development of convection near the core even more as those surface pressures fall, increasing convergence at the low levels. And with an increase in convection, you get more latent heat that's released, which leads to further pressure falls, and then the positive feedbacks spiral out of control, and that's how it develops into a tropical system. Right now, though, this is largely an open wave. There's no evidence yet of a closed circulation. So with an easterly wave like this, basically you have cyclonic curvature, but it's still an open wave. And once you start to measure those westerly winds, when the Air Force reconnaissance Hurricane Hunter aircraft begin to measure those winds with a westerly component, that's when there's evidence of a closed circulation, and that's when this will be named a tropical depression on approach to South Florida. It's going to pass over South Florida tonight, move into the eastern Gulf of Mexico, where the water temperatures, of course, are very warm this time of year. And I do think that there is a chance that if it doesn't become a tropical depression overnight tonight, it's almost certainly going to become a tropical cyclone in the eastern Gulf of Mexico. And there is even a chance that it could become a minimal hurricane before it makes landfall in the central Gulf Coast. So we're not only going to be discussing the tropics here, but we're also going to debut the design for the Surginator. That's our storm surge sensor that's going to stream live data of the storm surge height from along the coast. I'm hoping that we can deploy this in time for the next hurricane, but if that hurricane is early next week, then chances are a little bit lower of us getting the storm surge sensor out there. But I'm going to break down the Surginator that's been designed by Mark, or Chase and Spin on Twitter. And it's using a pressure sensor below the water and above. Also factors in salinity and the temperature of the water to adjust and correct that storm surge height. But these storm surge sensors will be capable of streaming that data live, so we're going to know what type of storm surge is impacting our sensors. But first I want to give you just a quick look here at the overall pattern. You've got that upper level low here over the central United States. This is the one that brought the snow to the Colorado Rockies and a devastating wildfire threat across the Pacific Northwest and California with that intense northerly flow, often gap flow getting forced between the terrain and accelerating, causing those wildfires to spread out of control. Finally, this upper level low is migrating east through the central U.S. It's allowed the Rockies to clear out a little bit after the last couple days of fog and snowfall up here, which is better than the smoke that's been happening. But I'm going to show you data that we collected with the Subsonic sensor during that intense Arctic blast, or that cold front that dropped south just to the east of the Rocky Mountains, basically a trapped bore surging off to the south. I'm going to show you some gravity wave data that we measured using the Subsonic sensor, and get a general discussion of gravity waves and infrasound waves that we're trying to measure inside these various storms. And here you can see Paulette. This is the 6-hour forecast from the GFS. So this is about current, showing Paulette here in the open Atlantic. You've got a Rossby wave train here in the jet, upper low that's getting picked back up with the jet, and then another upper low here in the northeastern Pacific that should provide some relief for the Pacific Northwest for that wildfire threat, maybe bringing in some precipitation moving forward. And this is just one model. This is just a GFS model. Here you can see the Bermuda High that is blocking, at least for right now, the turn to the north of Paulette. But this Bermuda High is going to slide off to the east, getting eroded by this upper level low, or this trough. It's lifting off to the northeast. This is a Rossby wave right here. There's a ridge upstream of that, the upper level low that's getting picked up by the jet that dropped all the way down to the Four Corners region. And once this Bermuda High slides off to the east, that's going to encourage Paulette to turn off to the north, impact Bermuda as potentially a major hurricane, and then lift off to the northeast as an extratropical cyclone. But first, that Bermuda High has to slide off to the east and then get that south to north oriented steering flow on the west side of that Bermuda High. There you can see the Bermuda High still, as of this weekend, that is starting to slide off to the east. And once that happens, it's going to make way for Paulette to lift off to the north, potentially very close to Bermuda, and get picked up by the polar front jet stream here, the Rossby wave train. You can see that this Bermuda High constricts off to the east as this next trough lifts to the northeast and erodes and constricts that Bermuda High. That's going to create a south to north steering current, and then Paulette is going to lift off to the north. And Renee will also be out here. That will bend back to the west due to Fujiwara interaction between these two storms. Interestingly, the GFS, at least the earlier run, the run that we're looking at now, doesn't really pick up much on this next tropical system that could become a tropical depression overnight tonight near southern Florida and then move into the eastern Gulf of Mexico. It's just too small of a storm. But still, it seems like the theme so far this tropical season is for there to be quite hostile conditions further out across the Atlantic. And then once these storms get into the Caribbean or the Gulf of Mexico, they really intensify and ramp up late. Laura did that off the west coast of Cuba. Hannah did that in the western Gulf of Mexico on approach to southern Texas. Isaias intensified late as well over the Gulf Stream on approach to eastern North Carolina. This system to the east of Florida is going to pass over Florida and probably develop in the eastern Gulf of Mexico. 95L is taking a further south track, could recurve, but many of the model members are showing a bend back to the west and potentially being a threat in the southeastern United States in about 8 to 10 days. We're just going to have to continue to watch the tropics here, as we've got a couple smaller scale systems that aren't really being picked up by the global models in the Gulf of Mexico. It's very possible that the system to the southeast of Florida could re-intensify. Here's the GFS picking up on a 95L that is now to the north of the Lesser Antilles. The latest operational GFS has that turning to the north, becoming a fish storm. But some of the other members take a further south track and bend it to the south, not being picked up by this large-scale trough. The European ensembles also show the potential for recurvature, but some of those members bending it back west and taking it to the south of this Rossby wave, this large-scale trough across the northeastern U.S. Look at this, another upper level low as well, toward around September 20. That could be interesting. We'll have to monitor that for some potential severe weather, but it looks like it flattens out upon ejection from the Rockies. And this GFS run definitely shows 95L lifting off to the north, constricting that Bermuda High off to the east, and then allowing this system to get picked up by that trough and transitioning into an extratropical cyclone across the northern Atlantic. So I really think that 95L, I wouldn't buy this as just one run recurving that storm to the north. There's a chance that it could be far enough south and could eventually threaten the southeastern U.S. But in the near term, we certainly have to watch this storm system that is just to the east of Florida. Could become a tropical depression tonight. And if that happens, I'll be heading to the central Gulf Coast for a potential landfall of even a Category 1 hurricane early to middle part of next week. So now I want to show you the Surginator video, and this was put together by Mark last night.
Inside the water start to separate. So
and there you can see, we'll listen to the audio and just let it run here for a little bit.
The little Mickeys here, that's water. Each one is water, and they tend to head over to the positive electrode. And then the sodium chloride, the salt, gets split up. The chlorine heads over to the positive electrode, and the sodium heads over to the negative electrode. This means that essentially our solution has been.
So this is Mark explaining why there's a difference between freshwater, brackish water, which is a mixture of seawater and fresh water that you often get as the rivers flow into these bodies of water, like the Gulf of Mexico, the Mississippi River into the Gulf of Mexico, for example. And then the difference, and also pure seawater. And so when you're measuring the storm surge height based on the pressure or the weight of the water, basically having a sensor below the water and also a sensor above, and measuring the pressure difference between those two to determine the weight or the pressure density of that water. So when you have salt water or water of different temperature, you have to factor that in when you're using pressure to measure the difference in the storm surge height. And this is Mark mapping out the design. Honestly, a lot of this engineering and even the science is definitely over my head, but Mark is an absolute machine when it comes to building these and coming up with these designs. Basically, I just approached him and said that we need to find a way to measure storm surge in real time and then stream that data back so that we know what kind of storm surge is impacting sensors like the windy palms. And we could mount these along the shoreline and along the rivers where the water is piled up when you get those tropical cyclones making landfall. But really the difficulty in measuring the storm surge height based on the weight of the water or using pressure sensors is to also determine the salinity and the temperature of that water. So if you know that the water is pure fresh water, or if you know it's brackish, or if you know it's salt water, you really need to ingest that data into this when you're measuring the storm surge height based on the pressure difference. So there's going to be a long wire with sensors on either side, and we're also going to want to have a gravity wave observatory above the water. You also need an antenna above the water that can stream this data live using the cellular network. So this Surginator that we're calling it cannot be entirely underwater, but also has to have an above water component that can stream the data live. It'll also be capable of measuring the real-time wind speed and the pressure perturbations associated with any gravity waves that might be generated by the hurricane. So this is a two-in-one type of a sensor that has both an above water component that's capable of streaming the data live and also measuring the gravity waves, the atmospheric gravity waves above the water surface. But it's also capable of measuring the salinity inside the water and the pressure difference that's created by the weight of water above that sensor. And so now I'm going to bring back Mark so you guys can hear more about his design.
Still water, got fresh water, and I've got brackish water, and finally seawater. And to do that, what I've done is I've essentially just weighed out some salt and mixed it with distilled water. I do actually have some seawater, calibration seawater on order, which should be here shortly, which I'm going to use for the final calibration. And to verify that I've got the right concentration of salt, I bought a refractometer from Amazon. Basically all you do with this, just put a couple of drops on there of the solution, put that down, spreads the solution out over the glass, and then you look through the eyepiece and there's a little graduated scale on there. And it's actually pretty accurate for measuring salinity. So we're just going to fire up the prototype here. So this isn't how it's going to look finally, but sometimes we just need to test these things first before we commit them onto a circuit board. And these are the two gold-plated electrodes I'm going to use to do the sampling. And then here's my sampling water here. So I'm just going to switch the unit on. So you can see there the waveform being generated. So basically you've got a negative and a positive waveform. So you can see it's being pulsed up and then it's decaying off. Then it's being pulsed down and it's decaying off again as it switches in both directions. So we have an AC signal. It's going positive, it's going negative, so that we don't electrolyze the water. And yeah, and then you'll see as I dip this in got a brackish water sample here. As I dip it in the sample, you see that waveform changes. So you can see now basically that waveform is now becoming a lot sharper because it's there's more conductivity in the liquid, and because it's conducting more between two electrodes, that's decaying off a lot faster. So I'm just going to expand that out a bit. You can see how fast that's decaying there. and are dropping off pretty fast. That's what we want to see. So we just need to measure the length of that drop off. So here's a quick demo. We've got our electrodes. We've got 4 different saline solutions. We've got no saline, which is distilled water, fresh water, brackish, and seawater. And then we've got our sensor at the back, which is feeding via Bluetooth to a web page, which we're running on the iPad. So you can see at the moment it's registering air because there's nothing connected to the electrodes. So I'm going to put it in distilled water. And you'll see it's changed to distilled water. Put it in fresh water. Let's pick up fresh water. Brackish. There we go, it's detected brackish. And then switch it to seawater. It's detected seawater. There you go. So hopefully we'll get a chance to deploy it this season. Thank you to all the Facebook supporters who've made this possible.
So really what Mark is working on here is he's trying to develop there's a difference in conductivity between water that has salt, the ions within the solution, and that between totally fresh water and also that with salt water. They have very different conductivity, and Mark is able to measure that in real time and then basically provide a real-time measurement of the salinity of the water that's coming in through storm surge, and then he's able to correct that data. So eventually, this storm surge sensor, the Surginator, is going to be able to estimate the height above normal levels that the storm surge is coming in, and it's also going to be able to factor in the difference in the pressure density that's created by salty water versus brackish versus purely fresh water. So the Surginator is going to come together, and we're going to mount a Surginator along the base of the windy palms trees. So we deploy Mike Tice's instrumentation. We're also going to mount this on the stilts at the base of stilt homes, since those are very sturdy, and we're going to measure this along the edges of those rivers and creeks that flow in to the body of water. In this case, are likely to be the Gulf of Mexico or the Atlantic Ocean this season. And then we're going to be able to stream this data live. So the Windy Palms unit that we deployed down in Holly Beach, for example, had probably about a 5 to 6 foot storm surge lapping up at the base of the box. That's why we believe some of that pressure data was a little bit distorted in the second half of the storm. And it'd be really fascinating to be able to know exactly how high that storm surge is that's impacting these various sensors. And again, really quickly, here is the official forecast track for Paulette. Forecast to approach Bermuda as potentially a major hurricane by Monday morning before doing a sharp U-turn, lifting off to the northeast of the western periphery of that Bermuda High and on the eastern side of an upper level trough that will be dominating the northeastern U.S. That's going to cause Paulette to become a fish storm, even though it's going to be quite substantial and quite strong. These are some of the intensity forecasts by the hurricane models. One of those members bringing it up to major hurricane status at Category 3. The official Hurricane Center forecast has it becoming a Category 2, even on approach to Bermuda, and then lifting off to the northeast. I would love to intercept the storm in Bermuda, but then I'm worried that it would take me out of play for the early next week intercept across the central Gulf Coast, or even 95L that is way downstream. And then looking at some of the other, this is the GFS ensemble predictions for 95L, which is just off the coast of Africa now. And you can see that the uncertainty with this system, some of the members recurve way early, some of the members a little bit later heading up toward Bermuda. That's probably the most likely scenario just based on climatology. And then you've got the southern members, and this one would be a threat to the southeastern U.S. So you have these different scenarios for 95L, but it's just too far out in the open Atlantic to determine what it's going to do. The European ensembles also show these discrepancies in the different scenarios that might evolve. Some of them recurve a little bit earlier, some of them towards Bermuda, along the western edge of the Bermuda High. And it all depends on this timing of and shape of the Rossby wave train and the polar front jet, and how it constricts the Bermuda High. Does that Bermuda High focus off to the east, and are there any weaknesses within the Bermuda High that will encourage a recurvature? And then it could lift to a high enough latitude to get picked up by these Rossby waves. So still a lot of uncertainty for 95L. Still even some uncertainty for the system just off the coast of Florida, but it could become a tropical depression overnight tonight before moving into the eastern Gulf of Mexico. Looking at the hurricane model intensity forecast, and these are from the incredible Levi Cohen's website, tropicaltidbits.com. And this shows at 95L a lot of different solutions. This one are a couple of those outliers that lift the system off to the due north. But for the most part, this 95L is likely going to become a pretty stout tropical cyclone as it lifts off to the west. At least if it sticks to those two scenarios, the one up toward Bermuda and the other one bending off to the west toward the Bahamas in like 10 days, 10 to 14 days. But still not a lot of agreement in the long-range global models with 95L. That is way out in the Atlantic, so still a lot to watch out there. But really in the short term, we're going to have to keep an eye on that system that could become a tropical depression over southern Florida overnight tonight and move into the eastern Gulf of Mexico for early next week, because that is definitely one that we potentially may intercept and bring scientific equipment out there. I don't think we're going to have the Surginator ready in time if there is an early next week type landfall, but we could have it ready in 10 to 14 days if 95L does threaten the southeastern U.S. So now I want to discuss the data that we measured with the Subsonic sensor during the recent snowstorm. And this was the coverage from that snowstorm. There was a scene from I-70 that got closed near the Georgetown area, creating basically a 5-mile long parking lot along I-70 right at the same time as those heavier snowfall rates were moving in. That did accumulate on I-70 for a little while, creating some slick spots. Overall, though, on the Colorado side, at least in the foothills to the west and to the northwest of Denver, this system underperformed a bit in terms of precip, with precipitation maxes off to the north in Wyoming and the foothills up there to the west and northwest of Cheyenne. Also a maximum in snowfall in the mountains over southern Colorado. Some of those locations recorded over a foot outside of Canyon City. But there were some, it definitely underperformed in the foothills to the west and to the northwest of Denver. And I think as it wrapped in a warm nose within the upslope regime, also some dry pockets of air, some dry slots were wrapping in with the upper level system, acting to erode the precipitation shield a little bit over northern Colorado. But this shows the difference between the day before, when there was that red sun, very dry, hot conditions, temperatures soaring into the 90s in the Denver International Airport, and then the arrival of that hardcore cold front from the north, and then snow back behind it as the upper level system closed off down near the Four Corners, bending those post-frontal winds into an easterly direction, forcing it up the terrain and squeezing out that moisture in the form of pretty heavy snowfall rates that continued for a little bit. But there were some warm noses that came in just above the ground, and that caused the precipitation to shift over to freezing rain over parts of northern Colorado. That likely held down some of those snowfall accumulations. The dry air that came in a little bit just as the upper system was closing off. There's a lot of dry air over the western U.S. and the low and mid levels of the atmosphere, and that was wrapping in to this upper level system as it was closing off, producing damaging winds across Utah, fueling those wildfires too across the western United States, California, Oregon, some of the worst hit areas from those wildfires on the backside of this upper level low as we got some of that gap flow. Here you can see some drone footage shot before the snowfall. And look at how dry the Colorado foothills are. Very different than the last few years when we had an active monsoon season up here and an active severe weather season through the whole entire summer into the early fall. We definitely are appreciative of any moisture that we can get out here, but we need another 5 or 6 events similar to the one that we had this past weekend to really put a dent in the wildfire threat and to help snuff out some of those flames like are being found in the Cameron Peak fire that expanded to over 100,000 acres burnt. I do expect now that that upper level low is sliding off to the east. We're going to return to that dry regime, the drought conditions, and I wouldn't be surprised if those wildfires reinvigorate off to the west and we see a dramatic reduction in air quality once again until that next upper level low arrives in about 7 to 10 days, which could bring in some more precipitation. But this intense cold front that was blasting off to the south because it was such a potent air mass, potent cold pool with an abrupt change in weather. Anytime you get a step function like that, a quick change in temperature from warmer temperatures to cold, or a quick change in wind direction, you get the generation of waves within the atmosphere, because the atmosphere behaves like a fluid, and you get waves within the atmosphere just like you do within water, or on the top of an ocean. You'll get waves, sometimes giant waves on the top of an ocean. In the atmosphere, you can also get waves on the top of cold air masses, basically along the top of a more dense cold air mass, and the interface between that cold air mass and warmer air mass. You can get wave-like motions. You can also get gravity waves that propagate vertically through the lower troposphere, depending on the static stability and other factors. Sometimes those gravity waves can be much longer scale. And this shows the range of frequencies of the different scales. The audio range, you can sometimes hear down to about 10 hertz at the very lowest. You can barely hear it. But anything below 10 hertz, and 1 hertz is basically 1 sample per second. Hertz is a measure of frequency out here. So these are the longer, slower frequencies, longer wavelengths. These are the higher frequencies and shorter wavelengths. And above about 10 hertz, frequency higher than 10 hertz is considered to be the audible range that we can resolve with the own human ear. And this in-between frequency, which is above the Brunt-Väisälä frequency, so if you were to take a parcel of air in a statically stable environment, displace it, whether you lift it up or bring it back down, it should return back to its original position, and then even oscillate up and down below and above that reference point at a frequency that is the Brunt-Väisälä frequency. And frequencies which are slower, lower frequencies down here, they're gravity waves. So these are considered gravity waves, and then anything above the Brunt-Väisälä frequency is considered infrasound. So our subsonic sensor is really designed to measure gravity waves between the gravity frequency and also infrasound. Mark and I consider these infrasound waves gravity waves, at least the lower end infrasound waves. And the Brunt-Väisälä frequency changes, as does the density of the air. So up here at higher elevation, the Brunt-Väisälä frequency will be just a little bit higher, and vice versa at the lower elevations. And we measured subsonic waves in the vicinity of that cold front that came through the evening of the 7th, I believe it was. So it'd be the evening of the 7th, and the snowstorm was on the 8th. And that was the range of those different waves. So now I'm going to show you some of that base data that we collected. These are the infrasound plots. So this is the data that we measured during that cold frontal passage, and this is at least the most interesting part of the data that happened just as that wind shift was happening. So you had a cold front, which is actually the temperature gradient, the transition from those warmer temperatures to the colder temperatures, and then out ahead of that temperature difference, you'll get a wind shift that propagates well in advance of the temperature change. And then you also get little waves that will be embedded within there. Sometimes that wind shift will propagate more rapidly, way more rapidly than the temperature change, and it starts to behave more as a gravity wave or a bore, basically trapped by the terrain off to the west, surging off to the south. And there are also smaller scale waves. The waves that we measured with the subsonic sensor are on a frequency of about 0.08 hertz. And so these are 8 to 10 second waves in duration. That's about how long they last. So these are very fine scale waves that we're measuring. And we measured 3 distinct peaks out here with the subsonic sensor. And this is the infrasound here. And you can see that these different waves went beyond the scale that the infrasound is capable of resolving. And so these were definitely bleeding in to the gravity wave frequency as well. Basically, you could see it as an oversensitive microphone, and if you get something that's extremely loud, it'll definitely have, sometimes the entire range of that sound is not capable of being resolved. And these are the different frequencies right here. These are the pascals, or the units on the left exit, or the left axis. And some of these waves, or these pressure pumps right here, even exceeded about 35 pascals, which is pretty substantial. These are big time pressure pumps. We believe that these were gravity waves that were hammering my apartment right as that wind shift arrived. It's possible that this was as those northerly winds were interacting with the complex terrain of the Rocky Mountains. But more than likely, these gravity waves were caused by a step function or a change in air mass from a relatively warm air mass to a very cold air mass. In this case, though, these gravity waves were propagating out ahead of the temperature shift, being trapped by the terrain to the west. They will dive off to the south, and these were three such pressure pumps, likely associated with some wind as well, that impacted the apartment. And interestingly, you can see a very sharp front face on these pressure waves. So there was a very intense pressure rise, followed by a bleed off of the sensor. Basically, there's a slow leak in there to get it back to a reference state so that you can measure these pressure oscillations. And even within that bleed off, you can see that there are gravity waves within there after that initial peak and as they tailed off. But this is basically the infrasound sensor leaking to return to a base state, and then more gravity waves and infrasound waves are being measured there. And these are showing the different frequencies with respect to time, frequency in hertz. And these actually spiked up to about 0.08 to 0.1 hertz, even a little bit beyond that. But we did have gravity wave sensors, so we were able to resolve the true shape of those waves. Basically a pressure whipsaw with a magnitude in excess of 35 pascals was observed by the subsonic sensor as this cold front came through. So now I'll show you what they looked like in a pressure sense. So this is zooming in on the first one. And this is from the gravity wave sensor. This is measuring pressure, showing the true magnitude of that first one, the first wave that we analyzed by the subsonic sensor. Let me pull up the right plot here. So this on the left is in pascals. And starting off low, you can see these waves coming up. And look at this one peaking and then dropping way down. There was another wave here afterward, but because the infrasound sensor was overwhelmed by this pressure pump, it didn't resolve some of these waves just afterward. And this is zooming in. This is just after 0Z on the 8th. So this is the evening of the 7th, which is when that front came through. The maximum temperature at the Denver International Airport rose into the low 90s late afternoon just before the arrival of this front, arriving in the foothills at around 6 p.m. or so. The gravity waves arrived first. So these gravity waves were sampled by the subsonic sensor later on that evening, 7, 8, 9, 10 o'clock. That's when the cold pool arrived and started to deepen. The temperature plummeted. Then snowfall arrived early that morning. And then we transitioned into a much more quiescent atmosphere with less gravity waves. There were some gravity waves likely on the top of that cold pool. But these ones that have these dramatic pressure swings of in excess of 35 pascals, which is pretty substantial, and lasting about 8 to 12 seconds in duration. So these are pretty short wavelength. This is state-of-the-art research that's not being done out there to measure these pressure perturbations on a really, really fine scale and determine which are gravity waves, which are infrasound waves, or if there even is a difference between the two. But this is a zoom in on that pressure wave, and very likely these pressure oscillations of 35 millibars are likely triggering migraine headaches throughout the front range as this was happening on the evening of the 7th. And oftentimes when you get these waves that exist on frequencies of lower than 10 hertz, sometimes you even get an uneasy feeling, even though you can't quite hear them with the naked ear. You'll still get an uneasy feeling when you get those frequencies that are slower, or frequencies that are smaller than that can be resolved by the human ear at about 10 hertz. So really we're trying to measure that heartbeat or voices that are being created by these different storm scales. And they're on frequencies that can't be resolved with the human ear, but you need a very sensitive microphone like what's in the subsonic sensor to be able to measure these different perturbations. This one, though, is the gravity wave sensor, so it wasn't overwhelmed by those frequencies that are smaller than that of the infrasound frequency. Then you can see these gravity waves as well afterward that are of lower frequency than the big one. This is time here, 0, getting close to 1Z at this time on the evening of the 7th. So these gravity waves were substantial with this front. Actually, the greatest magnitude gravity waves we've ever measured with the Gravity Wave Observatory, except for a shock wave that was measured up in Alberta by Braden Morrisseau. That one was about 105 pascals. So this is a little bit later. This is the second pressure pump, and the pressure continued to rise. After the arrival of the initial gravity wave that signified that initial wind shift, this was another pressure whipsaw that was on the order of much smaller than 35 pascals. This one was about 75, a little less than 20 pascals, the second one. So the second one was smaller. The third one was more substantial. And even after that, you could see some perturbations and gravity waves continue. But really, those three distinct peaks that were resolved by the infrasound sensor were pretty substantial. There you can see those a little bit better. The bottom one was the third gravity wave. And then you can see it return to more quiescent laminar flow after that one. So we basically had these three pressure pops or pressure whipsaws that came through ahead of the temperature fall. And those were gravity waves or micro bores that were surging to the south, trapped by the greater terrain off to the west. And then the dramatic temperature fall came. Overall, though, as the snow was falling, the environment was characterized by relatively weak winds, very slowly undulating gravity waves, likely on the top of that cold pool, none of which were even close to these massive pressure whipsaws that happened along the leading edge of that cold front. But just fascinating data from the infrasound sensor, and we still have a long way to go until we fully understand exactly the data that we're collecting here. And really, we need multiple sensors to be able to get a direction on which the disturbance is coming from. So eventually, once we get a whole network of these gravity wave / infrasound sensors, we're going to be able to track these different features during the whole entire duration. This was the initial pressure whipsaw, the largest one of about 35 pascals. This is the second one that just wasn't as substantial as the initial. And then this was the third one on the backside, basically acting as a gravity wave or a micro bore. But we still have a long way to go in these and fully understanding these. But really what stimulated our research on gravity waves was the Linwood tornado. When we launched the rocket into that EF4 tornado, when the sensor rode the tornado all the way up to 39,000 feet, at the top there were pretty large-scale pressure oscillations. They were high frequency, large amplitude, and obviously the amplitude of gravity waves goes up as you go into the lower pressures, especially high up in the troposphere. They have a much larger relative amplitude than they do at the lower troposphere, so they're much easier to measure by the sensor up in the upper part of the supercell. As the EF4 tornado was causing that severe damage down in Linwood, we believe that was triggering gravity waves that would propagate vertically within the supercell storm. And so now we're really expanding our gravity wave research, and Mark is definitely spearheading this work on gravity waves and infrasound and deploying these sensors inside things like hurricanes, cold fronts, discriminating between supercell, non-tornadic supercell storms and tornadic supercell storms. But just incredibly exciting research that we're doing with this infrasound, and it's all because of Mark's genius and being able to build these things, build all these sensors. And I just got an alert that a tropical depression has formed off the coast of southeastern Florida, Tropical Depression 19. I still need to verify that, but I do believe that this has been named a tropical depression, which means that Hurricane Hunter aircraft has been able to measure some westerly component winds within this, which means that it does have a closed circulation, and this tropical depression is on approach to southern Florida and is forecast to reemerge in the eastern Gulf of Mexico late this weekend into early next week, and then further intensification is anticipated on approach to the central Gulf Coast. So breaking news that you've got here during this live briefing on the tropics. I'm hearing that the disturbance off the southeastern coast of Florida has been named a tropical depression, and definitely the focus, all eyes are on that storm right now, and because it definitely has U.S. impacts as it will head into the Gulf of Mexico. Right now it looks like it's mainly going to be a rainmaker, but I've seen these things intensify when they enter into the Gulf of Mexico, and the further south track it'll have, the longer duration that storm will have over water, 3-4 days over water, potentially, and really having minimal land impacts as it moves over South Florida. So I think that a chance of an even a minimal hurricane is definitely on the table with this thing, and that's why anybody in the central Gulf Coast all the way along the western coast of Florida certainly need to keep an eye on Tropical Depression 19, which could become our S storm as it heads into the eastern Gulf of Mexico. Early next week into the middle of next week could definitely have direct impacts by a tropical cyclone there in the eastern Gulf of Mexico. So that's what I got today for this live briefing. Thank you, everybody. Thank you, Facebook supporters, for making our research possible. It's a grassroots effort, so we're just getting started across the board from our science to our disaster recovery, but we're headed in the right direction, and big things should be possible from a science perspective, from storm chasing, live streaming, and during these briefings, thanks to everybody here. So thank you, everybody. Have a great weekend, and I'm going to be back live tomorrow morning to break down the threat from TD19 as it heads into the eastern Gulf of Mexico. Thank you. Never stop chasing.